Hey, welcome back to Further Compound Interest. I've got a lot of formulas around the place here. Hey, what's going on? This is the one down here that Pearson's were using before, and this is sort of like what was on the calculator, future value and present value, rather than the amount after the time coming from the principal. And then this is something between the two of them. You've got A and P, but we've got I there instead of R. What's going on? And here's the calculator, present value, future value type notation. So I want to just adjust the formula a little and talk about how in practice investments return money, not just annually, a little bit more frequently than that. So come on down here, and this is what I've got for you. And the formula I think we should be using now is this one, a bit more universal, where you invest some money or you borrow, that's the present value, and it grows to a future value. And here the I is adjustable. Hey, what's that? Adjustable. Okay, it may not be just annually. Okay, may not be just annually. R, let's say, is the annual rate of interest back in the other formula, and this would be the number of years, but this is now the number of times we apply that interest to the money. And usually it isn't annually. Quite often banks will, or investments will, return you a payment, a dividend, and interest every quarter or every month, and quite often big transactions are calculated daily. So they actually calculate an interest rate on the amount at various numbers or various parts of a year, various times during the year. So this I has to be adjustable, has to be adjusted. You can't apply the annual rate, that's if the money's there for a whole year. If it's only there for a month, your rate, I, will be your R divided by 12. All in decimals. And if it's quarterly, it's a quarter of the year, the I will be the rate split into 4, because 4 lots of that will come to the annual rate. And guess what? What would this be? What would I be if, and R is a decimal, it's all got to be in decimals, R is the annual rate in decimals, daily, well, it would be split into 365. And if we did all that, we have to not just put years up here, but put in the number of years that we are investing for, how many times it would be applied. Let's do an example. So 3 years would equal 4 quarters in a year. It would be 12 quarters if we were doing it quarterly. Do you get the idea? It's just extending the formula to allow for other than annual rates. Okay? Generally it is worked out more frequently, quite usually monthly. Okay, let's go and have a look at doing a few bit more realistic problems. So Clive borrowed $12,000 to buy a lathe, a piece of machinery here, for his factory. He agreed to pay interest at 15% per annum and to repay the loan in full in 3 years. Calculate amount to be prepaid if the interest is compounded annually. Okay, so he's going to pay the interest at a rate of 15% per annum, just the interest then, and repay the loan at the end. Okay, so what is the amount? Okay, so that's going to be future value. Let's do this so that this is a bit more universal using this formula. And then, so our R here is now going to be I. So it's 12,000, the rate is 15% per annum, 3 years, same as the last one. Okay, so that's the same as the last one. But what if we go to half yearly? Still trying to find the amount, still the same formula. Let's use future value and present value. 12,000 is the present value, and R, it's done, R is divided by 2, because it's 6 monthly, which is twice a year. So you'll only apply that half of that rate. So it's 0.075, and in 3 years, how many half years would there be? 6. It would be done twice a year. For 3 years, 6 calculations. So it's 12,000, 1.075 to the 6th. These must match the time frame adjustment, must match the time frame adjustment. Okay, adjusting it from yearly to several times during the year perhaps. Okay, let's do the next one, quarterly, same problem. Okay, so here future value, present value, so there's 12,000. Now it's being done quarterly, so the 15%, the annual rate, is split into 4 times a year. You will apply that with the same effective interest overall, interest rate of 15% for the year. 3 years, how many times? 4 times a year, quarterly, every quarter of a year. So there'll be 12 calculations. So it looks like this. Okay, and you can see, I think, what's happening. The more frequently you calculate, more frequent calculations give you a larger amount at the end. Okay, so in a loan you don't want that, but in an investment it's returning more money. Okay, because you're compounding more often, more frequently. You're getting more interest on the interest because it's being added more frequently, and then it's available for the next interest calculation. Do you get it? Okay, might discuss that. Alright, let's have a look at another one. Here we have some problems. Okay, calculate amount to be repaid after 2 years on a loan of this if the 14% interest is compounded annually, half-yearly, quarterly. So that's the same as the one above. You just got to watch it here. Half-yearly, quarterly, so they're all different times or amount of time of calculation there. Alright, pause the presentation and see if you can apply that new, more general formula now. Future value is present value, 1 plus I to the n. These two need to be adjusted. Okay. Alright, I'll show you the answers now. Here they are for those, so see what you think and check it right down to the last cent. Money must be to the last cent. Let's go on and do some more. Okay, some understanding problems here. Okay, so we've got a monthly one coming in there. Okay, 12 months in a year, so do the adjustment on N and on I. Okay, pause the presentation and have a go. There's a daily one here. I'll show you the answers now. There are answers for those few little problems there, 5, 6, and 7. Okay, you want to have a go at a bit more challenging problem? Here's one here. Oh, wouldn't mind going there. Okay, somebody, Martina, won $5,000 in the lottery and decided to invest it with a view taking a trip to Paris. That's good. 2 options, so let's do 2 calculations. 4.5% compounded quarterly, or she could have 4.4% compounded daily. Well, the 4.5% looks higher. Okay, this looks higher, but this is done more frequently. Oh, which will grow more quickly if she leaves it there for 2 years? Okay, have a go. You've got 2 calculations now with 2 different interest rates and 2 different compounding times, quarterly versus daily. The question is, if you do a smaller percent daily, will it beat a slightly larger percent done quarterly? Interest on interest. Okay, have a go and see what you think. Here's the answer now. Okay, there's not much difference, but it's interesting. Okay, let's go down and have a look at some reasoning problems. Getting a bit harder now. Okay, and we've got some interesting questions here. Okay, here's a challenging one, an algebra one. Okay, see what you can do. Alright, let's have a look at the answers we've got now. These are all coming from Pearson's. Okay. Okay, so see what you have gotten out of that. You might have to talk to your teacher about that one. Okay, last few now. Have a look. Open-ended questions coming from Pearson's textbook there. And there's just a bit of a discussion needed here. And this is worth discussing with the rest of your mates and so on, and with your teacher. Okay, let's have a look at what the book put now. So pause it, have a go yourself, and then come down and have a look at this. Okay, and read those and have a discussion about that. Okay, compound interest, interesting stuff. Lots of interest in compound interest, and it's an important aspect in the world today. Alright, in banking and so on. So what I want to do now is there's just one more presentation on compound interest, just a further little advancement on it, and see what you think. So I'll catch you then. Cheers for now.